Hello class. Today we are looking at properties of parallelograms. Your essential question: how do I prove properties of parallelograms? Your learning intention: I'm learning how to use the property of parallelograms to prove theorems. So this is our warm-up question. State if the triangles are congruent, state the congruence. Which triangle congruence criteria guarantees part 1? Pause the video and see if you can figure it out. I do hope you try it on your own. Remember, we've got those 5 triangle congruencies. Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. And hypotenuse leg. Hypotenuse leg is for right triangles only. Remember, there is no angle, side, side congruency. Side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So, as I look at this, I notice that I've got the right triangles going on. So my first thing I will check, are the hypotenuses congruent? So as I'm looking, I don't know that they are. So that tells me I cannot use HL. But what do I know? Okay, so if I'm looking, I notice that segment FI and segment GH are congruent. Okay. I'm also noticing I've got those two 90-degree angles. All 90-degree angles are congruent. So angle I is congruent to angle H. Okay, I've got one angle on one side. I need another angle or I need another side. Which do I have? Let's start by highlighting the two triangles. There's the first triangle. Here's my second triangle. What do you notice? If you said you noticed that these two highlights fell one on top of the other, they're the same segment, you are correct. So we know that IH is congruent to HI. Now, if I read this, side, angle, side. The triangles are congruent by side, angle, side. Triangle FIH is congruent to triangle GHI by side, angle, side. Any questions? Okay, so let's look at the property of parallelograms. Opposite sides are what and what? Well, the first thing is actually in the name. They are what? If you said parallel, you are correct. And if you said congruent, you are correct. Okay, the symbol for parallel are two lines straight up and down. The symbol for congruent is an equal sign with a sideways S up above it. Okay, opposite angles. This is a parallelogram. What do we notice? What looks to be true about opposite angles, A and C, or D and B? What looks to be true? If you say they are congruent, you would be correct. Finally, diagonals do what to each other? Begins with a B. Bi. Bi means how many pieces? 2. Sect. If it bisects each other, it means it cuts it into 2 equal pieces. So we're going to look, and we're going to look and show that if we draw a diagonal, we've split that parallelogram into 2 congruent triangles. So, executive decision, do we want to go from A to C for our diagonal, or from D to B? Let's try from D to B. Okay, so what we want to show, WTS, we want to show that triangle ABD is congruent to triangle CDB. That's what we want to show. Okay, now, with proofs, 99% of the time, you start with what is given. 100% of the time, the last statement is what you want to show. So I don't know how I'm getting there, but triangle ABD is congruent to triangle CDB. But how do I get there? Step by step, how do I set this up? Okay, what do we do first? What do we use first? Well, we use our given information. So we start with what's given. Okay, we have parallelogram ABCD. With diagonal. Segment BD. Okay, that's what it told us to do. That's what we're given. That's how we start. Okay, so let's break down that given information. Parallelogram means what? How do I know it's a parallelogram? It's right in the name. Opposite sides are parallel. So let's look at our opposite sides. AB has to be congruent to DC. Segment AB is parallel to segment DC, not congruent parallel. So I'm going to do that there. But that's not the only sides that are parallel. Segment AD, side AB, is parallel to segment BC or side BC. How do I know that? Well, it's the definition of a parallelogram. So by definition, a parallelogram has opposite sides parallel. Okay. Now I've got to think a little bit harder. If I look up here, I see that I've got these parallel lines going on. That diagonal is actually a transversal for those two sets of parallel lines. Okay, so parallel lines, transversal, which angles are congruent? Do I have any exterior angles? No. I've only got the interior angles. So, which interior angles are congruent? The ones on the same side of the transversal or the one on the alternating or opposite sides of the transversal? If you said alternate, you are correct. So, A, B, B, angle A, D, B is congruent to angle D, B, C. The other pair will be congruent also. Angle C, D, B is congruent to angle A, D, D. These are alternate. Interior angles A, I, A. Now, from here on, we will use the shorthand for it, AIA, alternate interior angles. Okay, I've got two angles that are congruent. I have to have a side. So I'm going to take a minute and highlight the two triangles that I have. As I highlight, what do you notice? What has happened? I've highlighted that diagonal with both of my colors, which tells me that this segment has to be part of both of them and it has to be congruent to itself. Segment DB is congruent to segment BD. That is, what is it when it's congruent to itself? Think about looking in a mirror. Reflection, reflexive. Your reflexive property says anything is congruent to itself. And finally, I'm to the end. I know that the two triangles are congruent. I look back up here and I've got an angle, side, angle. Okay, I have proven what I wanted to prove. So I'm going to tell my reader I'm done This tells my reader the infinity sign, says I'm done. Look it over, see if you can find a way to argue me out of my statements, but I don't think so. As you set up the proofs, look at what you're given. When I looked at what I was given, I'm given this parallelogram. So immediately I start thinking, what does parallelogram mean? Well, we've got parallel lines, parallel sides. So by definition, I can use that. Okay, I've got those parallel lines. I've got that transversal. If I've got parallel lines cut by a transversal, which angles are congruent? That's where the next statement comes from. Then I look again. I've got that overlapping piece. I've got that piece that is part of both triangles. So I use that, and then I've proven that my two triangles are congruent. That's the way you set up a good proof. Okay, we're given a parallelogram ABCD again. Prove that the diagonals bisect each other. Okay, this time instead of one diagonal, I need two. Okay, they have a point of intersection. I need to label it. I've got A, B, C, D. The next logical thing would be E. So we'll call the point of intersection E. Okay, I want to prove that the diagonals bisect each other. I want to show WTS. AE is congruent to EC. And segment BE is congruent to segment ED. Because if the pieces are congruent, that means that it has been cut in half, it has been bisected. So we know what the last statement needs to be. What is our first statement? 99% of the time we use the given information. Parallelogram. ABCD with diagonals. AC and BD. Okay, how do I get started? How do I think about this? Okay, I know I've got a parallelogram, and I know that the opposite sides are what? Parallel and congruent would be true. So the first thing I've got to do is look at the picture. I've created what? My parallelogram has been divided into what? 4 triangles is correct. So what I need to do is to prove either the top 2 triangles are congruent, or the top and the bottom triangles are congruent, or the 2 side triangles are congruent. So I'm going to highlight because I want to show that they're congruent. If they're congruent, then their corresponding pieces are congruent. I'm going to do the top and the bottom. So the top triangle. And the bottom triangle. Okay, so how are we going to start? Parallelogram. What do I know about these two lines here? They're parallel. So I can start by saying segment AB is parallel to segment BC. We also know that they are congruent. So I can also say segment AB is congruent to segment BC. Those are opposite sides of a parallelogram. Okay. Now, I've got one side. I've got to prove two angles of those triangles are congruent. So, as we're looking, what stands out first for me is the fact I've got these two intersecting lines. What were the very first angles we taught you were congruent? Begins with a V. If you said vertical, thank you. That's what we're looking for. We know vertical angles are congruent. So we know both sides here are congruent. We know that angle AEB is congruent to angle DEC. Vertical angles. Okay, now I need one more pair of congruent angles and I'm done. I've got a parallelogram. What reason, when we had a parallelogram, what reason did we use in our last proof? What reason did we use in the last proof when we had parallel lines cut by a transversal? Interior, what kind? Alternate interior. So make an executive decision. I can use this angle or I can use this angle. I've decided to use angle BAE and angle DCE. Angle DCE is congruent to angle BAE. Those are our alternate interior angles. Okay, I've got two angles and a side. Is the side located between those two angles? No. So this one would be angle, angle, side. Triangle ABE is congruent to triangle. A has none. A has two. C has two. B has none. C, D, E. And that is by angle, angle, side. Okay, I've gone to a lot of work to prove two triangles are congruent. What will come next? Well, our last statement will come next. Segment AE is congruent to segment EC. Segment DE is congruent to segment ED. How do I know? Corresponding parts of congruent triangles are congruent. Okay, last statement. If the pieces are congruent, what do we know about the diagonals? They bisect each other. And that is by definition. So as we do our proofs, each piece builds on the piece before it. Sometimes we have them standing alone by themselves, like the alternate interior angles, but that's built off of the fact that we've got parallel lines. Something like vertical angles stands alone. So there's different ways to set these up. This is one order we can use. There's other we could have actually put the vertical angles up above the parallel lines if we wanted, or we could put vertical angles down below the alternate interior. Or we could have just used two sets of alternate interior angles. So there are different ways to do your proofs, but you've got to use definitions and what we know about our parallelograms to prove things. I know I'm successful when I can use the property of parallelograms in proofs. So these are proofs with parallelograms.